Hi, this is going to be quite a long video, so hopefully you can stay with me until the end. It says find the equation of the incircle of a triangle with the vertices a minus 7 minus 2, b 5 3, and c minus 7 3. Now, if we draw the diagram, so here these are the vertices of the triangle, this is the incircle, we're going to need to find two things. One, the centre of the circle, and b, the radius. Now I know in this question I could find the radius quite easily by doing this one, but it's a bit more challenging to find the radius using this one. Okay, so we need to do a little bit of theory. So the centre of the circle you get by taking the angle bisector of two of the vertices, which I've done here, and that gives you the centre where they meet. Okay, but we will need to find this point here and this point here in order to find the equation of these lines so that we can find where they meet. So this requires a little bit of theory. So drawing a diagram, so we've got triangle ABC, where this red line here is the angle bisector. Okay, and what we're going to do is we're going to use the sine rule. First of all, on triangle ABP, this one here. So as this is opposite C, I'm going to call this C. I'm going to call this one X. And then this angle here, I'm going to let be alpha. And then this angle here is theta. This is also theta. And that's because this one's alpha. This one is also 180 minus alpha. So sine theta over X is equal to sine alpha over C. Call that equation 1. We're going to call this side B and this side Y. And then using this triangle here, we're going to have that sine theta over Y is going to be equal to sine 180 minus alpha over B. Now, the sine of 180 minus alpha is in fact the same as sine alpha over B, and we'll call that equation 2. Now, so from 1, we're going to make sine theta the subject. So sine theta is X sine alpha over C. We're going to substitute that into this one instead of sine alpha. So we're going to have X sine alpha C times the Y. So the Y was already there, is equal to sine alpha over B. The sine alphas will cancel out, and we'll end up with the ratio of X over Y is equal to C over B. And therefore we can say that BP over PC is the same as AB over AC, and we're going to need to use this relationship. So we've got A is minus 7 minus 2, B is 5 3, and C is minus 7 3. So we're going to go through and find all the distances of each side of that triangle. Okay, you're going to use that formula, which you should know. So for AB is going to be 5 minus minus 7 squared, so 5 minus minus 7 squared plus 3 minus minus 2 all squared, which will give you 13. I'm going to repeat that for BC. So BC is going to be minus 7 minus 5 all squared, and then 3 minus 3 all squared. That's going to be 0. That will give you 12. And then CA is going to be minus 7 minus minus 7 plus 3 minus minus 2 squared, which will give us 5. Okay, using the idea that BP over PC is AB over AC, we can say that 13 over 5 will be the same as BP and PC. If we look at the CB, okay, that means that P will belong here such that this is the ratio of 5 to 13. Therefore, we can find that CP is 5/18, so it's 5 over 5 plus 13 eighteenths of CB, and CB was 12, and therefore that will give me that it's 10 over 3. And then we can take the x-coordinate of C. So we're now going to find the coordinates of P. The x-coordinate, which is minus 7, plus 10 over 3. We don't need to do anything at the y-coordinate because B also had a y-coordinate of 3 as well. So P has coordinates minus 11, 3, and the y-coordinate will be 3. Right, so now we can find the equation of the angle bisector of A. So A was minus 7 minus 2, and P is minus 11 over 3. So using the gradient formula, which you should know, and then making sure you put things in the right order. Sometimes it's a good idea to write this in first. So you're going to have 3 minus minus 2 minus 11 over 3 minus 7. Be careful with the negative numbers, which will give you 3 over 2. And then using y minus y1 is equal to mx minus x1. We'll just take the coordinates of A. So y minus minus 2 is equal to 3 over 2 x minus minus 7. That will give y plus 2 is equal to 3 over 2 times x plus 7. And then doing the arithmetic, so taking 3 over 2 into the bracket, and then subtracting 2, we're going to have that y is 3 over 2x plus 17 over 2. So that's the angle bisector at B. Now we're going to find the angle bisector at B. So we've got AB is 13, BC is 12, CA is 5. And then using that ratio idea, that CQ over QA will be BC over BA. So CQ is going to be CQ over QA will be 12 over 13. So drawing a line again. So this will be 12 and this will be 13. Okay, and then the CQ will be 12 over 25 times CA. So it's 12 over 25 times CA, which is 12 over 25 times 5, which will give me 12 over 5. So using the y coordinate of C, the x coordinates were the same. Q will be minus 7, 3 minus 12 over 5. If you remember, C was at the top and A was lower down. So that's going to give me minus 7, comma, minus 3 over 5. There should be a comma in there. Anyhow, finding the equation of the angle bisector at B, we're going to use 5, 3, and this point Q minus 7, comma, 3 over 5. We'll do exactly the same before. We'll find the gradient, which is 3 over 5 minus 3 over minus 7 minus 5, which gives me 1/5, and then we use y minus y1 is equal to m times x minus x1. So it's minus 3 is 1/5 x minus 5. So y minus 3 is going to be equal to 1/5 x minus 1, and y will be 1/5 x plus 2. That will give me equation 2. If we find where equation 1 and 2 meet, we'll find the centre of the circle, as I said at the initial point. So at the point of intersection of 1 and 2, we're going to have that 3 over 2x plus 17 over 2 is equal to 1/5 of x plus 2. This is just a linear equation. So 13 over 10x is equal to minus 13 over 2. Found the fraction button on the calculator very, very useful in this problem. And therefore x is minus 5. Okay, we'll substitute that into equation 2. And we get y is equal to 1/5 times minus 5 plus 2. And therefore y will be equal to 1. So the centre of the circle, in circle, is minus 5, 1. Now I know we had a right angle triangle, but now I'm going to actually try and find the radius. And what we need to do is find a line perpendicular to, say, one side. We're going to say AB. We could have done, it might have been easier to do the other two sides because the right angle triangle, but we're going to try and do it from the hypotenuse, which will require a little bit more thought. So A is minus 7, 2, and B is 5, 3. And we're going to find the gradient of AB, which is going to be 3 minus minus 2, 5 minus minus 7, which will give me 5 over 12. Therefore, that will call that 3. And the perpendicular gradient will be minus 12 over 5. Okay, so equation of the line through O and a gradient minus 12 over 5, which is that perpendicular that we're dropping down, will be y minus 1 minus 12 over 5 x minus minus 5, which will give me y minus 1 minus 12 x plus 5 will give me y minus 1 minus 12 over 5x minus 12. Adding 1, we're going to get y is minus 12 over 5x minus 11. We also now need to find the equation of the line AB. So we'll need to find the gradient AB, which we've already found, which is 5/12 from 3. And therefore we're going to do y minus 5/12 x minus 5. We just need to take one of these two coordinates. I took b because these were both positive. I just thought it might be a bit easier. So y minus 3 will be 5 over 12x minus 25 over 12. Be careful to use fractions, yeah? So y is 5 over 12x plus 11 over 12. It sort of backs up the idea of using the fraction button. Okay, well, 5. We now need to find where 4 and 5 meet. Okay, so we'll put minus 12 over 5x minus 11 is equal to 5 over 12x plus 11 over 12. So rearranging, we're going to get minus 169 over 60. So we're taking minus 5 over 12x over here and adding 11 over here. We get 143 over 12. X will be 143 times 60 over minus 169 will give me minus 55 over 3. Substitute back into 4, or 5, it doesn't matter. So minus 12 over 5 times minus 55 over 13 minus 11 will give me minus 11 over 13. Right, now we need to find, so we've now got a new point to find the radius. It's going to be the distance between O, the centre of the circle, and that point we found on AB, which is minus 55 over 12, minus 11 over 13, which is point R on the diagram. Using the distance between 2 points, we're going to have minus 55 minus minus 5 all squared, plus minus 11 over 13 minus 1 all squared, which will give me 2. That's nice and convenient, which is what we thought it would be. Therefore, the equation of a incircle, centre O 5, 1, R 2. And so the equation of a circle is x minus a all squared plus y minus b all squared is equal to r squared, which will give me x plus 5 all squared plus y minus 1 all squared is equal to 4. Okay, so that sort of refers back to this diagram, which we've got here. So what we did, to find the radius, we dropped down this perpendicular. We found this length here. I appreciate you could very easily deduce that it's 2 from here just by subtracting the x-coordinates, or the same here by subtracting the y-coordinates. But this was a bit more challenging, and I thought it'd be a bit more interesting for this problem. This is a GeoGebra app, which will be, the link will be in the notes of this problem, along with the link of my video site where you find loads of videos to help you with A-level maths, and maybe you could consider subscribing to my channel. Anyhow, thank you very much for watching. Well done if you got to the end, and maybe see you in the next one.